Hi guys, we're going to be reviewing what we've already learned today on adding, subtracting, multiplying, and dividing decimals. We did this back in the fall. I know that seems like forever and a day ago. Um, Sorry about that. But we are going to be reviewing. These notes should go into your composition book, but you don't have to glue them in right now. But we're going to go over adding and subtracting. If you recall, when we add and subtract numbers, we have to make sure that we are putting things into like groups. So I can only add ones to ones, tens to tens, tenths to tenths, etc. And what separates those is the decimal point. And therefore, you have to make sure that when you add or subtract, you have to line the decimal point. Let's go over just briefly the rules. They're written here. It says rewrite the expression vertically. What does vertically mean? Up and down, correct. Just like when doing adding whole numbers, you need to line up the digits by place value. When we have whole numbers, though, it's easy. The last digit is the ones place, and so on and so forth, so it's easy to line them up. But when you have decimals, the place value is determined by where the decimal point is. Okay, so for part 2, it says use the decimal point to help you line up the place values. The decimal point for each number being added or subtracted must be in the same location for each number. And if there are any missing digits, use zeros as placeholders. Okay? So we are going to go through and we're going to do some of these questions together. And I don't think I'm able to zoom this. I'm sorry because the recorder button is there. But let's take example 1. We have 3 and 2500ths plus 9 and 6700ths. Think of this as money. If I bought, let's say, what cost $3.25? Lunch for $3.25 and dinner for $9.67. How much money did I spend altogether, essentially? So we can take, and I usually like to have wherever there's more digits before the decimal place on top, but in this case they're the same. So I'm going to add 9 and 6700ths, and I'm going to kind of cheat a little bit. I don't need to rewrite it. Let me get my cursor out of there. So I have to make sure that my decimal points here are lined up, and then you simply add them as if they were whole numbers without decimal places there. So 5 plus 7 is 12. Carry the 1. 6 plus 2 is 8, plus 1 is 9. We don't have to carry anything, but we've got to bring down that decimal point. And then 9 plus 3 is 12. Okay? Let's look at example B. Well, if you look at example B, we've got some crazy numbers here, but I'm going to line them up because 97 is greater than 7, and it has more digits before the decimal point. I'm going to line the 7 decimal point underneath it, and that would be read as 7 and 587 six thousandths. So we have 586 thousandths. And if you recall, it says over here, where there are any missing digits, use 0 as placeholder. So we're going to add 1, 2, 3 zeros here. And now we can add. Okay, so then this is easy. 6, 8, 7 are going to stay the same. 5 and 6 is 11. Carry the 1. We have 9 plus 3 is 12. Carry the 1. Gives us an 8. Bring down the decimal point. We didn't need to carry anything over, so 7 and 7 is 14. Carry the 1, and that's 100. Anybody want to take a stab at reading this number? Okay, here's how you would read it. 104 and 821,687 millionths. Thank you very much. All right, when we subtract, here's where we have to be a little bit careful, however. When you subtract, you can't add or subtract in any order you want, just like addition. You have to subtract in the order that it's given. Okay, so I can't decide if I want to move the 9 and 6700ths underneath it. I've got to bring the 2 and 4500ths here, and I'm going to subtract it from. Okay, that subtract from means that that number is actually going to be last. It's going to go after. When we subtract, remember we may have to borrow, so we're going to subtract 7 minus 5 is 2. 6 minus 4 is also 2, no borrowing yet. Bring down the decimal point, and then 9 minus 2 is 7. We didn't have to borrow anything. That's nice. All right, the last example. We have 584 and 3/10 minus 6 and 934 thousandths. I know that there are 4 digits for each number, but I don't line up the digits. I line up the decimal point. Therefore, I'm going to have a 6 here, and then the 9, 3, 4. But because we're going to have to add some zeros, I'm actually going to rewrite this problem. I have 584 and 3/10 minus 6 and, line up the decimal points, 934 thousandths. So in these placeholders here and here, we're going to add zeros. Okay? And we're going to subtract. So I'm going to need to make this a 10. I'm going to borrow, that becomes a 9, right? But technically it's not a 9. In order to make it a 9, I have to have borrowed from the 3. That becomes a 2. I'm going to have to borrow from the 4. That's going to become a 12. And that's a 3. Borrow from the 8. And that's a 13. That's a lot of changes there. Okay, some of you I know like to borrow as you go along. You can do it either way. But now I have 10 minus 4 is 6. 9 minus 3 is 6. 12 minus 9 is 3. Bring down your decimal point. 13 minus 6 is 7. 7 and 5 are left. 577 and 366 thousandths. Okay? All right, we're going to move on to multiplying. Okay, some key things. You notice the asterisk up here. In order to line them up, you do not need to align place values to multiply decimals. In fact, it will just give you extra work. So you simply line them up as if there were no decimal points there to begin with. Okay, the decimal points become a factor at the end. Okay, so let's look at the steps. Step number 1, write each number all the way to the right. So you just line up the digits, don't worry about the decimal points. Multiply as if you would if it was a regular whole number. And then you count the number of digits that are to the right of the decimal point in each number altogether. Okay? And then you're going to count back. So starting at the far right side of your product, count the number of digits. You count it in step 4 and place your decimal point there. All that's a little bit confusing, so we're going to see it when we do the problem. Okay, again, you're going to want to line these up vertically. I tend to, when I multiply, like to have the larger number on top, but it really doesn't matter. And you can multiply in any order you want. Okay, so think of it as multiplying 54 times 35. You don't need to worry about the decimal point to start. Okay, you're just going to do basic multiplication. So 5 times 4 is 20. Bring down the 0, carry the 2. 5 times 5 is 25, plus 2 is 27. And then remember, because now we're multiplying in the tens place, this line is going to be 10 times greater than the one before it, so we have to put the 0 there. Okay, 3 times 4 is 12. Carry the 1. 3 times 5 is 15, plus 1 is 16. Add the 2 numbers. And now here's where we need to take into account the decimal point. Okay, the decimal point movement in both the numbers is a total of 1, 2 places. So we have 1 place plus 1 place is a total of 2. In any whole number, the decimal point is found here at the end. I have to multiply a total of 1, 2 places, and that is where my final decimal point is going to go, meaning that my final answer is 18 and 90 hundredths, or you could just leave it 9 tenths. You don't need that 0 at the end. Okay, let's look at example B. Okay, we have 53 and 6/10 times 8. Do me a favor, stop the video right now, try this problem by yourself and then turn it on to make sure that you have the correct answer. All right, let's look and see. We have 8 times 6 is 48. Carry the 4. 8 times 3 is 24, plus 4 is 28. Carry the 2. 8 times 5 is 40, plus 2 is 42. We now have one total place value. Decimal points at the end of the number, so I have to move it one place value here, leaving my final answer as 422 and 8/10. Here, I'm going to rewrite this example D over to the side because one value has, sorry, I don't know what my thing's doing here. Because one value has 4 digits and the other has 3, I'm actually going to line the 4 digits on top. And the second one on the bottom. And notice I'm not lining up the decimal points, I'm only lining up digits. Okay? All right, so when I multiply, I'm going to multiply it just as if they're whole numbers. And if you want to stop here and try to do it on your own and then check, that would be awesome, but you don't have to. But I'm going to multiply. I'm going to try to go really quick here. So I have 12, carry the 1, 42, 43, carry the 4, 18, 22, carry the 2, and 32. Now, since I'm multiplying by the tens place, this line will be 10 times greater than the one before it, so I have to place the 0. And now I have 10, carry the 1, 35, 36, carry the 3, 15, 18, carry the 1, 15, 16. And the 3, again, we're looking at them as if they are whole numbers, discounting the decimal places that are there. So I'm going to be multiplying by technically the hundreds place if there's no decimal points. So I have to put in 2 zeros because it's 100 times greater than the one before. And I have 3 times 2 is 6, 3 times 7 is 21. So I'm going to bring down the 1, carry the 2. 3 times 3 is 9, plus 2 is 11. Carry the 1. 3 times 5 is 16, or 15 plus 1 is 16. Add it all up. Now we need to go back, excuse me, to our original numbers and see how many total place values. We have 1, 2, 3, 4, 5 total place values. Oops, sorry, that is 5 total, but this is 2 here. So that means I have a total of 5 place values. I need to move the decimal point. So I have 1, 2, 3, 4, 5, placing the decimal point there. Giving me a final answer of 17 and 12,432 hundred thousandths. All right, division. Division's a little bit different. We haven't done this, but we're only going to be dividing a decimal by a whole number. We're not going to do a decimal by a decimal this time around. I think they'll get to that in 6th grade, so we don't have to worry about that. We're only going to do a decimal by a whole number. And with that, there's not a lot we have to do with it. These directions here are if I had a decimal divided by a decimal. You can keep them there as reference, but you don't have to know all of it. Here we're going to set it up where we have 32 and 7/10 divided by 3. Okay? When you have a decimal divided by a whole number, you simply bring the decimal point up. And then you divide it as if you were dividing 2 whole numbers. Okay? So we have 3 goes into 3 1 time. 3 goes into 2 0 times. Okay? Which then leaves me with 27, and 3 goes into 27 9 times. So then your answer would be 10 and 9/10. Sorry if I went a little too fast on that one. All right, example 2. I have 298 and 2/10 divided by 7. Because we're dividing a decimal by a whole number, I simply just need to bring this decimal point up here. And then I'm going to divide as if it were a whole number. I'm going to go ahead and extend my page. Thank you. 7 goes into 2 0 times, but 29, 4 times, sorry. And that's 28. And hold on one second because I'm going to need to move this. There we go. I'm not going to have enough room. Subtract gives you 1. Bring down the 8. 7 goes into 18, 2 times. I was thinking 14, hence the 4. 2 times, which would be 14. Subtract, and that would be 4. Bring down the 2. And 7 goes into the decimal point, just stays where it is. 7 goes into 42 6 times. So our answer would be 42 and 6/10. All right, example 3, I'm going to write over here. I have 517 and 6/10 divided by 8. All right, so I'm going to bring up the decimal point. It stays in its place. 8 goes into 51 6 times, that's 48. Bring down the 7. 8 goes into 37 4 times, and that would be 32. Subtract. 5, bring down the 6. And 8 goes into 56, 5, 6, 7, 8 times 7. So that would be 56. And so your final answer would be 64 and 7/10. All right, there are some practice problems for you to do. If you could do those really quickly, and then if you finish those, the rest of the period is yours to work on homework. Thank you.